simulation, and then we build out modular parts, and then we do the actual analysis on them, and then we pick the best one and we put it on the actual vehicle. Okay, that comes later. That comes later. Hopefully, that's something that we can all do and that we should shoot for next year, your final year here. That's what our goal should be. We should build something that looks cool, that can move up and down, we can push around. It's not too hard. We can make something that looks pretty decent, okay? So with that, what I would say is over the next week, you guys should design something. Either design a submodule, front suspension, rear suspension, driver's seat, dash panel, the whole cart if you want to, okay? Build something and run some basic analysis on it, okay? Just anything you've learned in class so far. Some stuff you may not have learned yet. You may not learn until your third year, okay? But that's okay. Just build what you know. And what I would recommend, let me see if I can share my screen here. What I would recommend, let me try and share my entire screen, and then I'll move my video down here so we can see. So this is the first link, okay? This is the first link. This is what I'm sending to different universities to let them know about this program and what kind of support myself and UCI can provide. So VGU, of course, is our primary university we're talking with right now, but we're also talking with a couple other universities because you need multiple universities to be invested in this for people to have some kind of competition, okay? But in here, the important one, if we go all the way to the end, we have all these resources, okay? Here's where I recommend you start. This already has a bill of materials. You don't need to build your own, okay? You can still continually build your own over the year to specify for the real race car, but this here can be your real race car. This thing will cost you less than the 20 million that you're given to build this if you do it right, okay? You talk to Professor Hien, he can get some of this stuff. You start showing us that you can CAD this, that you can show all the different simulations. We can probably get stuff from the US as well, so you don't have to spend all your budget on it, okay? It's loading right now. This one doesn't have the blueprint. I can actually ask.
Sorry, Professor, I'm not hearing anything. Are you speaking?
1 second. Network loss.
Oh, there it is.
One second here. All right, my internet's a little unstable. But you guys can hear me again, yeah? Good?
Yep.
Okay. We're just waiting for this to load a little bit. So this is definitely something we can start and build with, and then we can improve it from here, okay? Hopefully it eventually loads. Here we go. Okay, I'm gonna try and get you guys blueprint for this, but you don't have to build it exact. Exact is not important at this moment, okay? Because none of these parts are, most of these parts, you probably won't be able to buy off the shelf anyway, so you have to fabricate or design in some capacity. But a lot of details are given. So the main thing here is it has a roll hoop. That's the important part. That's the safety feature, okay? Then it has all these other bars. So that's what you test in your design. You can say, hey, look, this design here can support 2,000 pounds of pressure or whatever it is. Entire car and driver is only 200 pounds or 300 pounds. Safe. The vehicle is safe. So you can definitely show something like this is safe, especially with the simple motor that's in this one. It won't even go as fast as the go-karts at Dynam, but that's okay. Your first version doesn't have to go that fast. Your first version just has to work. If you look at the motor here, we can easily swap this motor out with a different motor from an e-bike or from a scooter, and just minimum changes, and then you'll go twice as fast. Okay, and then we keep building it. And of course, some of you may not be interested in electric motors. You can get a gas engine for it. That's totally fine. It's just changing the mounting points, changing how it's controlled. Everything else works the same from the user perspective. Okay, but what's important is that you show, hey, this is how all of this connects. So I would encourage you to actually spend time looking through this document and looking through this competition and building the bill of materials out of this design here. Okay, this one should, I don't know if it has it on this document or not. There might be another document, but if you look it up, it's the Formula 24 kit. Okay, you should be able to find a lot of information on it. So the reason why this one's here, and again, look, same company, Siemens sponsors this one too. Okay, so this one came about to provide an affordable race car program for a lot of schools trying to participate in this. Okay, so technically speaking, this car itself will not be allowed to race in the FSAE competition because it won't meet the technical requirements, but it's a very good starting point. All the software you're using, the way you're building this vehicle, it's exactly the same. Okay, so I think we should try and build this vehicle over the next year. Okay, possibly the next 2 years. I think if you can build this vehicle in 2 years before you graduate, I think that would be a huge success, because this is something you can showcase. Okay, and then if you want to make it look a little bit more like the Formula cars and stuff like that, it's actually very easy. You change out the wheels and you're done. You change out the wheels to be the proper Formula wheels, you put a little bit of suspension on it, and it will look just like any other Formula car. It won't be as fast, again, but that's okay. Those are things we can fix. Once we start getting more sponsors, we can probably get sponsors for the engine, the battery, if we're doing electric, things like that. Okay. So yeah, so to give you some reference point, where we use this at UC Irvine is we didn't use it for our cars. We ran our own competition with high schools. So we ran this competition with high schools, and the high schools built these, okay, and they competed, and we hosted the event, and then eventually we changed it into a solar car or a solar car with battery type situation, and they built efficient race cars, and now they make their own designs. But this all happened over the past 10, 15 years, okay? So they started here. And the reason why they're able to build their own race cars now, a lot more schools compete. A different company has taken over the competition because we gave it away. We don't have time to run it anymore. Is because they built something that they could keep building on top of. So I think this is a very good platform to start with, especially since there's literally no race car program in Vietnam. Okay, so you have to start with something that's simple as possible. Okay, and even something like this, I'm pretty sure if you build it and you run it at the local go-kart track, you'll still have a lot of fun. Okay, you'll still have a lot of fun. And yeah, so you just go through that. So I would recommend starting there. Do look at the rules and competition, but don't spend too much time on it. Just look at it for ideas, for inspiration, things like that. If you want a longer term goal, you look at the starting a Formula SA team from scratch. Okay, this website here, designjudges.com, this is maintained and written by all the judges who actually judge and run the competition. And in particular, many of them are FSAE alumni, meaning they've actually built and raced their cars when they were students as well. And now they're participating as judges, okay? And tech people, things like that. So they create these articles because these were things that they were missing when they were students. So now they're sharing it with everybody else. So this, again, is going to be a lot more than you can reasonably do in the next year or two, but it will give you some ideas. This is how teams over there do this when there's already a program. So your difficulty is there's no program that exists right now, so it's hard to do all the steps that they have listed. But a lot of things you can potentially replicate. Okay. All right. That's the main thing. Do we have any CS people here on this call?
I believe no. Is
Okay. Okay. So the main reason why I want you to also include CS people or at least EE people is if it's all mechanical, you're going to be very limited in what you can build in the future. Okay. As soon as you do an EV vehicle, you're going to need EE people. You're going to need CS people. If you want to be able to do any kind of major changes later, once you have the car built and doing analysis, the mechanical engineering stuff will work, but having a CS person on your team or an EE person will give you a lot more options, right? This team is really interdisciplinary. Every single car company has mechanical, electrical, and computer engineers. You just can't have a company without all three. Okay. For now, focus on the mechanical side. But even though you're on the mechanical side, one thing I do want everybody here to look at, okay, and see who can do it, because there's very many of you, so you can split these things up. If you're going to do any kind of analysis, or if you're going to do any kind of driver training later, you need some way to collect data, okay? And this is going to help with your report later too. And a big part here is once you get the CS majors involved, there's going to be a lot of other things that you guys can work on. And it won't be your main thing, but faculty will be interested. If you can show them that you can do some basic stuff, faculty will hop onto the project and they'll do research with you. And then you'll get research experience doing different subsections or submodules of this race car, and it will turn into a research paper. Okay, so that's why I included these other links. And again, I know that you're not specialized in this area, but I believe all the mechanical engineers still have to learn some kind of circuits, right? A little bit at least. You know, transistors and chips or anything? Do they teach you this at VGU?
No, they don't.
They don't? You should tell them. They should teach it. Every other big high school, or not every other big university teaches it. I teach programming to mechanical engineers also, okay? Because you need a basic foundation here, just because cars are no longer analog. I understand a lot of vehicles in Vietnam are still analog, but any modern car is no longer analog. Mechanical engineers need to know electrical systems. Okay. This one's not a super hard one. This is just connecting a bunch of parts. Okay. Just connecting a bunch of parts. You can build a system like this. If you can build a system like this, we can sell a system like this in Vietnam to all the local racers here. You guys don't have a data logging system. I could not find one searching in Vietnam that does what we need it to do for karting, for car racing, anything like that. So if you can build a system like this, do you learn how to model stuff and do 3D printing, right?
Yep.
Okay. So don't worry too much about the circuit. Worry about putting things together and going, okay, can we try and build something like this? You won't be able to build it in the next week because you haven't been taught how to do it. But I would encourage you to look through this one and see if that's something you think you can do. Okay? Super cheap device. Doesn't cost more than, I think, $50, so like 1.5 million or something. And that's something I can easily sponsor. That's not a problem at all. It's just a few modules here. And you put it together. And I think there's already schematics and everything available. You just got to get it actually printed. And Professor Hien can help with this. He's an electrical engineer. Okay, so he can help you work on this. He can help find you some EEs. But I would encourage the people here to learn this as well. If you're mechanical and you can build something like what you see here, you're going to be very valuable later on when people are hiring. Okay, because they can see that you can do a lot of different things. And now the next one I know is even scarier. Okay. But this is something that I think is fun. You should work on it as a team. And the main reason I want you to think about this one is because this is a competition you can absolutely participate in the next year if you get the right people. Okay, you absolutely can. The materials are a little bit of expensive, but you can actually do a lot of simulation ahead of time. So the F110th competition, so this is going to be more relevant for the Bosch Future Mobility team, but I think one or two people here also can participate, learn, and then there's different things you can do that you can use to your advantage later on, now that you have a mechanical engineer on the team, things like that. Okay, there's an RC race car, but the big thing is there's a lot of things you can build directly through simulation. And all of this actually translate back to regular race cars. And so everybody has a reference point. FSAE Germany and FSAE Australia, who are basically the leaders of FSAE in the world, they've moved on, and some of their competitions with these race cars are autonomous. So they've actually been competing autonomous against each other. Okay. So all of this stuff that you learn here for this little car will translate over to that stuff later. And also, just from a practical standpoint, knowing and learning some of this will make you a lot more useful in industry when you get hired later. For any automotive company, any autonomous company, any technology company that works with either drones, vehicles, boats, planes, things like that, having this knowledge will transfer over. Okay, because the algorithms are the same, the complexity is different. Granted, the stuff you'll be working on would be more complex, but if you can show them that, hey, look, I can map some stuff, it runs around, easy peasy. Okay, this does take a while to set up, but it's something you should at least read through. And there's even videos that show you. So I would like everybody, regardless of whether you're interested in this or not, I would like everybody to at least watch the first video. Okay, so from the F110 link, if you go to the autonomous racing course, you don't have to go through the whole course, but you watch the first video. It's just 30 minutes. Okay, and the big reason why I want you to watch this video is even if you're not interested in F110, everything this professor talks about is exactly the same stuff you do in FSAE. Okay, he talks everything from the practical side, making it affordable, building through simulation, testing the simulation, and then putting it on the real car and testing it, and then refining it. Exact same process, but way cheaper. Okay, an FSAE car will easily cost you $20,000, $30,000 if you're doing it over in the US. I'm pretty sure over here in Vietnam, we can do it for $10,000 to $20,000 US. I know that sounds crazy expensive right now because that's as much as like what, a VF3, right? But you guys don't worry about that. Your professors will worry about that, okay? You guys worry about designing stuff and we'll figure out how we can build it. We'll find sponsors. Once you start building small things, people will get excited. They'll want to get on board, okay? The racetrack owners we're talking to, they all want to see you succeed, okay? You're going to start meeting more of them as you start building these things. They're going to help you. And another part here, toward the end of this video, he starts talking about the research side, okay? The research side. So this is good for both you and the faculty that are potentially advising you. For you, even if you don't work in the automotive industry, even if you don't work in the autonomous industry, being able to translate some of the stuff you're working on into research will give you that advantage, okay? That's where it's going to set you apart from the other graduates, especially since I heard many of you end up applying for master's programs in Germany, things like that. Doing research is a huge thing that you should have in your portfolio. So some of the stuff you're working on can translate into research. And within 2 years, I'm positive you can come up with some kind of innovation if you have a faculty advisor working with you that you can publish, okay? And then on the faculty side and on your administration side, the leadership of your school, if they see that, hey, there's research implications and papers possible, they'll be more likely to support the program, even though you haven't competed yet, okay? And what we're hoping is some of your partner universities in Germany will help also support from their end that this is a good program, the FSAE program in general. because many of the German universities actually participate in FSAE. Okay, so the professors there would know a lot more about it. But yeah, please go through that at minimum. Watch the video, look at the F24 stuff, look at these links, and come up with kind of a new plan. Okay, and on the practical side, again, because there's so many of you, on the practical side, I would say start modeling something, whatever it is you learn. Have you guys built any kind of suspension yet? Or designed any kind of suspension in one of your classes yet?
We did it for our race, VRC race before with our RC's car.
Okay. So start with something from there and scale it up. Scale it up to a go-kart size. Pick a part. You don't have to rebuild the whole thing, but scale it up, show a part, and you'll be like, here's what we can build. Okay. So for example, one of the things I think that if you get the computer science people, meaning the Bosch future mobility people, plus you together on a team, and you start working on the F110 stuff, F110 doesn't have a strong mechanical engineering presence right now, which means they're relying 100% on algorithms, which is okay because this whole program was built by electrical engineers and computer scientists. So they're interested in the control theory, and that's what they focus on. But if you want to win the race, you need to have more data. You need to have properly designed suspension. You need to place the components in the correct place so they can adjust the center of gravity. They don't have a huge focus on that. Okay, that's a secondary focus. And that's where you can have an advantage if you end up going to these competitions. They host international competitions. They run one in Korea every year. So we get a team that can build this. We can figure out a way to get you guys money from the school or from other sources to have you compete in Korea. I think that'd be great, right? So your racing club can focus on whatever you think is interesting for your members, okay? On my side, I'm just presenting different options that you can look at because different people will have different motivations, okay? And a really hard thing to keep motivation on is if you're trying to build a full race car, like an FSAE car, and then you realize it's going to take 5 years to build. It won't take 5 years, but it can. A lot of people won't want to build anything, okay? So I think the same thing that your lab engineers and whoever you talk to said, which is build it in pieces, build modular pieces. I think that's just as important. We had to show those things at our presentations as well. So even though you see a full race car, you'll often see jigs set up where they show, here's different design suspensions, here's different steering designs that we have, and here's the different ways they work, and this is why we ended up with the one we have. Okay, that applies across the board. So yeah, I know that's a lot of stuff. I want it all done by next week when I see you guys. Okay, just kidding. Obviously, it's not practical to finish everything, but show me some progress. Okay, if you show me a CAD model of literally anything that's related to what you want to build, I think that would be fantastic. Okay, show me some summaries or plans that you have, just a bullet point list based on some resources you looked at. Okay, and my challenge for you is every single member should do it. Every single member should be responsible for something. I know some of these you're going to be working on together, but every person should take responsibility for one item. You go, okay, I'm interested in building the GPS data logger. Okay, I'm going to find me one of the computer science people. We're going to get together and we're going to figure out a plan. Here's the plan. We read through the website. And here's our approach. Okay, I really do encourage you to try and build that 10 hertz GPS device. Okay, to give you a reference point, I can easily just buy one in the US for $100, and that's what most people do. Okay, we buy one for $100, so that's 2.5 million or so Vietnam dong. Okay, over here, you don't have that device. You can build that device for, I would think, under $1 million easy. Okay, under $1 million easy. And once you build that device and we make it nice, first, The main point is for your own use, so that you could bring it with you go-karting, and you could get data, and you can improve driving, things like that. That's just a fun side of it. That's nothing you really have to even focus on until you actually have a car that you can run, or close to having a car you can run. But it's something fun to do. So if that's interesting for you, that's what you should focus on. But the bigger practical side for this, for everybody here, is if you can build it for 1 million, and we build some basic software that it's compatible with, we build a little package, I am sure we can sell it for 2 million. And you can probably find 30, 40 customers, which means soon you'll have $400, $500 million to build the next thing you want. It's probably one of the best ways you can fundraise for your group, which is you build things that people need and that people could use. And I'm sure we could sell it to the go-kart tracks. We could build a system for them, because we were looking at systems. So let me show you something. Okay, and I know you're mechanical engineers, but it's a whole team. Everybody works together. Let me look this one up. Hold on. Aim card dash micron. This stupid thing right here. Let me just show you this. And I don't even know if you can get this in Vietnam right now. I think you can. I think when my colleague was looking it up, it's somewhere around like 10 million plus Vietnam dong. Okay. Simple little dash, you attach it to your steering wheel, you get your lap time, your speed, things like that. Okay. You can build this. You can build this with the stuff, even as a mechanical engineer, you can build most of what you see here. Obviously, having an electrical engineer will help, but these are things you can build both for yourself to make it more affordable, as well as sell it. You can sell it. You sell one of these things, you make enough money to build another part on your car. Or you'll make enough money to go go-karting for a day for the whole team, things like that, right? And we can find you, there's a whole group. There's the Go-Kart Vietnam group on Facebook. So they all race together. They don't have, I haven't seen, I'm going to meet with more of them soon next week as well, but I don't think they use systems like this, because karting and racing is a fairly new thing in Vietnam, and there's not a lot of resources right now. So unless you have a lot of money to import stuff from the US or from Japan, you just don't have access to it. So if you guys build something that works, I'm sure they'll want to support you all and the local universities versus buying these more expensive ones. And then at that point, you don't even need university funding. You'll be able to fund it yourselves. Or you can just start a business after you graduate and sell stuff. That's what some FSE alumni have done. Okay, they just start their own business based on the stuff that they learn. So there's a lot of things you can do. It just depends on your own motivation and what you want to get out of it. Okay, so my task for everybody here is do something. Do something that you can show a report and you be like, here's what I built, or here's what I designed, or even here's the stuff I looked at or I read, and this is what I want to do over the next few weeks or over summer while we have a break. Okay, as long as you're building something that's potentially useful for either yourself, your team, whatever it is, then you can make progress toward building a full-on race car, right? So you can show me that, and again, it depends on your motivation. Okay, right now my plan is actually I'll probably only be spending a week, maybe longer. I will stay longer if there's stuff to do. Okay, but right now my plan is to stay about a week in Ho Chi Minh City next week. I'll be there later on in the week, probably the 9th or the 10th, and then I'll be there for about a week, and then I'm headed back up here for work. But I can stay longer if there's a project we're working on that I need to be or you want me to be around for. Okay. And my current plan is I'm headed back to the US early in July. But again, if you guys are working on something that requires a lot of time and feedback and things like that, I can change my flight to be later in July if there's a reason for us to meet during that time. That's not a requirement. That's just if there's motivation and opportunity, then we can make that work. Okay. Outside of that, I will be back tentatively every year. I'm not sure exactly which months yet, but of course, if you guys are building the team out and working on stuff, I'll be able to meet with you guys and give you some feedback. I can bring some parts back from the US, okay, as a reference point. I could bring back some 10 hertz GPS devices that you can use. That's not a big deal at all. Those are things we can figure out and we can arrange, okay? And of course, I'm available online, things like that throughout the year if we need to meet or we want updates, things like that, okay? And if you don't want to do any of it, that's also okay. That's fine. Really simple thing, and what I suggested for your university as well, that would, I think, keep all of the members engaged and give you an idea and a one-time cost, or hopefully a more of a one-time cost thing, is actually to purchase you guys a racing simulator, okay? That will end up costing significantly less than trying to go to the go-kart track all the time. Go-kart track is fun, but it gets really expensive, okay? So unless you have a particular plan and strategy that you want to do there, I don't think it's very practical to spend that much money there, okay? What I do encourage you to do, because the owners did seem open to it, is I do encourage you to talk with them and continue to talk with them, because I'm pretty sure they'll give you an extremely discounted price to run there. The last time Jai said he'll just charge you tires and gas and not the whole cost. But you got to work out that deal with him, okay? Come up with some proposal, whatever it is. They're willing to work with you guys because they like seeing new racers, okay? That might be a good opportunity. But a racing simulator, you can both learn driving in there. So we might be able to sponsor you some parts, and then the school covers some parts and give you space. We get some software for you guys. You guys could run on there, and you can just learn how to drive. And the nice thing is even the video games now, the ones that just cost $50, $60, even the video games use similar data analysis software as professional race teams, okay? And they use the same thing that engineers use to make changes to the vehicle. So you can actually learn how to tune and adjust the vehicle based on a simulation that will actually transfer later into the real vehicle as well, okay? And the nice thing there is we can get you a lot of support. You won't be going into this blind. We know a lot of racers and engineers over here in the US who do this stuff. And they'll be happy to give you workshops. There's plenty on YouTube, but those have some assumptions, meaning they assume you know some stuff already. So we can get you some virtual workshops. They can walk you through some of these things. They can probably give you some feedback. You could race with some of the racers over here. There's a lot of different things you can do. Okay, so I think I'll talk with Professor Hien, and I think getting a racing simulator would be one of the best things you can do. Also, you can use that same platform to do autonomous research, which again will tie into other things and give the university another reason to sponsor one or two of these machines, because multiple groups can use them. Okay, and then you'll just be in charge of it because you'll be the VGU racing group. But all right, so what do you guys think? How does that sound? What sounds the most interesting to you?
Oh, for our team, I talked with the few members, and the current plan for VRCs is to first to arrange a annual RC race to find future members for the team, and we also are looking for we're also looking to build a car, like an actual car. So we agree that we maybe we will follow the plan you got us, the Formula 24 one.
Mm-hmm.
The problem right now is that we are not having a lot of budget right now.
Yeah.
So yeah, I would like your advice for that, because the only way for us to get some kind of money is to either as a sponsorship, which we also have to cover some costs,
Mm-hmm.
and if we want the full budget, we have to go through the research department. And I don't. Oh, we are. I am also getting a few ideas, research ideas for the car as well. But yeah, the main problem right now is the budget to build a test car.
Yeah. I wouldn't even worry about the budget. That's my advice. I wouldn't worry about building a full car this next year. Okay. I would focus on making a CAD. If you can make a CAD over summer, you will get a budget. Somebody will give you a budget. The problem with giving you a budget now is you guys literally have no idea how you're going to build anything right now. Okay. It's going to be too much pressure on you to build this right now. We could give you $10,000 right now, but how are you gonna what are you gonna do with it, right? Uh, every team worries about budget. Every team never has enough money. Don't worry about the money yet. Worry about the money later. Let Professor Hien worry about the money. Okay? Show him that you deserve the money, that you should get the money. Okay? So what I mean by that is if you have a fully catted F-24 car and you show, hey, look, we've done the FEA analysis on this. We're ready to build this thing. It's safe. It will fit a person. We know we have the bill of materials for it. We've run it through simulation. We want to build this. It's going to cost this much money. Or we could build this sub module first. It will cost this much money. So once you have that, then now you can easily justify how much you need, where you need parts from, things like that. So the reason why I tell you this is because, for example, let's say we do the F-24 and it costs $2,000. So that's about 50 million. Okay. And let's say your school is only able to sponsor 20 million. So you'd be like, hey, we only have 20 million. We can find the other 30 million from outside sources. Okay. Especially if we can show them, hey, look, we're serious. We built this. We know who to build or how to build these things. Okay. So the easy way around this would be certain things we can actually get from the US. I'm willing to chip in from my side to help you guys get this started. I won't sponsor the whole race car. I simply cannot. Okay. But I can get you some parts that your university might not be able to get you. For example, I can get you a motor. That's not a problem. Okay. I can get you electronics. That's not a problem. Those are easy things to ship from the US to Vietnam. Okay. That could fall on our side because there's a collaboration between the universities. I want to see it run. If you can show me that you're ready to build it, that there's other support, we can help make it happen, right? And once we do that, we can do other things. So for example, we're like, oh, we're going to need to weld. So we talk with the lab engineers, right? Or we talk with local industry partners. There's so many companies around you guys that will probably be happy to weld. They'll be like, sure, put our sticker on your car, advertise us, we'll weld this up for you, right? A huge thing you can do is just ask for time, meaning time on the 5-axis CNC machine. You can build some really cool parts on there, which means you can build some really cool parts for some companies as well. And you can work out the deals with them, okay? And again, it's not all on you. It's just ideas that Professor Hien or the lab engineers can help facilitate, things like that, okay? What we need from you guys is to show that, hey, look, on the no budget side, here's what we can do with no budget already. Here's what we've been able to show. There's a huge interest. We want to build this, okay? And you know Professor Hien, he's been sponsoring a lot of projects out of pocket, right? He shouldn't do that, but he really likes the programs you guys are all participating on as a whole, especially for the RC racing and everything. So he'll put out some money for this as well. We can make it a reasonable race car. Okay. So on our side, if you guys really show us that you can CAD this, you can build it, you built the team, you can build the simple car, Professor Hien and I can cover the F-24 car. That's not a crazy amount of money. Okay. It won't be the fastest car, but I'm telling you, once you build it and you drive your own car that you built the first time, it will still be just as fun. Okay. But our goal is to build a much better car, but don't worry about that yet. Just show us. Okay. If you can show that, we can make the rest happen. And the first thing you can show is about a week from now, you show us what you've designed. We're not expecting a full design, but show us something, right? Even if it's something like, hey, look, we did the RC race car. So we took this part of the RC race car and we're considering it for our full race car. So we scaled it up. We ran this analysis. Here's load testing on it, whatever it is. Okay. And you're like, cool. Here's where we can go from there. Okay. Other things you can keep for now, as an example, you can keep the FSAE car or the full race car purely in CAD, and we focus the money on your RC competitions. Okay. The reason why we might want to focus on that is because that one you might be able to do really well in and place very high, which means now you're showing that you're a proven winner, right? Much easier to get sponsors, much easier to get further research money. We're just scaling things up for FSAE purposes. That's all any of this stuff is, okay? It's just scaling things up. And then once you scale it up so a human can fit inside of it, it becomes so much more fun and a lot more people want to get involved. But the RC one is totally doable, okay? I can get you guys a second RC the next time I'm back. I have several RCs for autonomous research as well, okay? And I know that you guys are doing gas engines from the last RC car race I saw. Are there any restrictions for using electric motors?
We use electric motors.
Okay. The one in Nhietjiang that I saw for the RC.
Oh, that one. The one we have. Yeah.
Yeah. Okay. The electric motor is just a lot easier to deal with. Okay. But the pictures you guys showed me of the RC car you're using, it's not a very good RC car. You need a better RC car. Okay. I get you guys a better chassis that will actually work well. For anything high speed, that thing's not going to work well. But it's okay for now, right? You're like, that's what we're building. We can compete, and it's equivalent to other cars. But you're going to want to start moving toward more sophisticated models, I would say, pretty soon once you start doing bigger competitions. Okay. Those are things we can figure out and we can get you guys access to. Okay. We have a lot of RC chassis. I just donated like 15 RC chassis to groups over here. So we're low now, but we still have a couple big ones that are very fast. Okay. And you can tune that. Real suspension, everything. So you can make all the modifications that you do as mechanical engineers. It's all there. We'll try and bring some back for you next time, but depends on what you need. Okay. All right, guys. Thanks for the update. One thing I would like before I come back next week, within the next couple days, talk with each other, okay, and come up with an initial plan. You're like, here's the people who are going to be working on stuff this next week. Here's what each person is doing, okay? Just a couple sentences is totally fine. Send that to me via email so that I can have a record of it, and then we can meet next week, okay? We can meet next week in person. Sound good?
Yeah.
Yep.
Yeah.
Okay, fantastic. All right. We'll figure something out. Awesome. Exciting, guys. There's a couple other schools wanting to build race cars now too, so you might have competitors, okay?
I want that.
But they don't have a racing club yet, so you're ahead so far. So you got to keep that momentum. All right.
All right.
Okay, everybody. Woo! All right.
Let's go.
Any questions, concerns? Any other questions, concerns before I get off this call? Everybody good?
Our team is good.
The document, Khan was included in it. You just got to look at the previous replies because I forwarded it to him. But I'll go ahead and forward it again. Can you guys maybe paste your emails in the chat or something, and then I'll just add you right now? Or actually, David, you have all their emails, right?
Yeah, I think I can send them.
Okay. Can you just forward that that email I sent out from the 23rd, the one with all the links?
Okay.
And then I think that'd be a good starting point. But Khan, you should have it. You just got to look at the replies. Yeah. You just got to go back a few emails. That's all. But okay, cool. Any other questions, concerns?
I just want to give an update. We already got permission to use the waiting room in our faculty
Okay.
cluster. I
Nice.
talked with the responsible lab engineer, and he agreed.
Okay. Okay. Fantastic.
Yeah, and I think we can work on the 5-axis CNC machine as well.
Okay.
I know the operator, so maybe I
Okay.
can check it out.
So we can. You guys can probably fab up at least the main cart chassis like this summer if you wanted, because that part isn't expensive. That's just metal and
Yeah.
welding. So that might be something you can actually fab up, and that'd be a fun thing to be able to display and take around, because people can start seeing, oh, a real race car is getting connected soon. Because that can't cost much money at all. It's just tubes and welding, and I'm pretty sure you have a tube bender there, right? And if you do, some company would have it. Tube benders are cheap. They're not
Yeah.
expensive.
I think we do.
Okay, yeah.
We should. Yeah, so that's just the update.
Okay, that sounds fantastic. Good job.
Yeah, thank you.
All right, cool. I can't hear you at all, Khan. I can't. Yeah, it's so noisy. Oh, I can hear you now. I can hear you now. Okay. Oh, no, 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 no. I'm doing a personal visit there, so I'm already in contact with them. Yeah, yeah. Oh, there's no need. I already have their contact. Yeah, yeah. Yeah, thank you. Okay, great. All right, guys. Thank you very much. Looking forward to seeing you all next week.
Us too.
Okay, have a good
Have a good one, you too.
See you next week.